So we're now on to looking at our first type of hypothesis test, and this is going to be a one sample proportion test. So we have some basic steps that we'll talk about that we go through in a hypothesis test in this section and in the coming sections as well. So one of the first things that we're going to do is we're going to state our significance level. So this always should be chosen at the beginning of our hypothesis test, and our most common ones that we choose for alpha are going to be let me change the color of my pen. 0.01, 0.05, or 0.1. Those are usually the three most common. Then we're going to state our null and alternative hypothesis. So we talked about how we write null and alternative hypotheses in the last section. For this, we used mu in the last section. Because it's a proportion, we're going to say P, population proportion. All right, so population proportion. It's going to be equal to P sub naught, right, some value. And then, again, as we saw, right, we're going to have three options for our alternative. It could be that it's not equal to, and this would be a two-tailed test. Oops. Let me rewrite how to spell tailed. There we go. Tailed test. It could be H sub A. It could be greater than, right? So greater than would be a right-tailed test. Right-tailed test. Or our last option, right? It could be less than P sub naught. And this would be a left-tailed test, right? And so I'm going to sort of gather them all because it's the null and then one of the alternatives based on the way that the question is worded. So we'll state our alpha level, state the null and alternative hypothesis. We then should state and check the assumptions for a one population proportion or a one prop test hypothesis test. So the first thing is we always want to make sure that a simple random sample of size n is taken, right? Everything needs to be randomly sampled. B, the conditions for the binomial distribution are satisfied. So we talked a little bit when we talked about binomial distribution, right? That, the events are independent. There's an end, right? It just doesn't infinitely continue. So, you chose 10 things or 5 things or so forth. The probability of success is the same for each of the events, and the probability of success does not change. So they're, again, sort of that independent. C says to determine the sampling distribution of P hat, you need to show that, so N times P, so the sample size times the population proportion is greater than or equal to 5, and N times Q, right? Where if you recall, right, from our binomial distribution, Q is equal to 1 minus P. That's greater than or equal to 5, right? So where Q is 1 minus P. If this requirement is true, then the sampling distribution of P hat is well approximated by a normal curve. So this P hat I keep saying, right? This is my sample proportion. So this is, if you look down at step 4, calculate the test statistic. This is P hat, right? So it's a little maybe harder to see on the paper. Sample proportion is the number of successes, or X, divided by the number of trials. Our test statistic is P hat, and let me write this just a little bit again. P hat minus, so the sample proportion minus the population proportion divided by P times Q divided by N. Now, for a p-value, we will use our calculator to help us find this. I'm going to show you sort of both ways. You can actually use the calculator for pretty much all of this. The calculator will calculate the test statistic, sample proportion, and even the p-value all in one nice step. I should say that with p hat, so p hat is equal to p, what we say prime, they mean the same thing. So you may see some of this notation, one or the other, in some of your homework. So just to note that they do mean the same thing. But again, we will actually use our calculator to find the test statistic and p-value. What we need to enter in our calculator is p naught, what proportion they are claiming, xn, and the type of tailed test. So we'll go through and sort of do a hypothesis at the end. We're still talking about sort of how we set up this hypothesis test. So step 5 is determine the type of tail. So remember, this is really done with the alternative hypothesis. So hang on, let me go back. Sorry, I know I keep going back up. Let me add one more thing for this p-value. So my p-value, we've talked about probability before, but my p-value is the probability of observing a value of the test statistic has extreme or more extreme than the value actually observed, assuming the null hypothesis is true. So we always assume the null is true unless we can find evidence to suggest otherwise. So p-value, in order to conclude the alternative hypothesis, the p-value has to be very, very small, right, as an extreme. So that's a little bit about the p-value. More to come as we go through and actually do our first hypothesis test. So step 5 now says to determine the type of tail test, right? So the right tail test, if it's a right tail test, we can actually, let me draw a picture of what this would look like, right? So if it is less than, if the null, it should be, I'm looking at this and I'm like, oh, I think, let me cross this out. So it should say, if it's a right tail test, the proportion is greater than this here. I think I have my signs flip-flopped. So if this is the case, if it's a right tail test, right, I draw my picture here. All right, so for step 5, again, it says determine the type of tail test. And as I'm looking at this, I notice I think I have a typo, or I do have a typo here. So I'm going to have you cross out. This should be a left tail test, and this should be the right tail test. So if I'm looking at all the notation here. So if it's a left tail test, my lower limit is going to be negative 99,999, and upper limit is your test statistic. And then it's going to be 0, 1, right? So p is less than p naught. If I were to draw a picture here, right? So I have some z here, and this is going to give then my p-value. Right, and my mean, right, my mean is here. This would be 0, but that's my mean. And so we're trying to determine, right, is the test statistic, this z, how far away is it from the mean? Is it an extreme value to suggest that, it is different than the null? If it's a right tail test, again, upper limit's going to be 99,999. So you'll have your test statistic. You'll have 99,999, 0, 1, because it's a standard normal curve. So if I draw my curve here, right, here's my mean of 0. And maybe you have your test statistic, and here's, your p-value. And your test statistic, right, it could be positive, it could be negative, and it could really be anywhere. But in terms of the way we shade, if it's a right tail test, it should be shaded always to the right. Left tail to the left. Now a two-tailed, we haven't really seen this too much. So if I drew my curve, we're still going to go through and do the same thing. So, right, my mean is at 0. Here's my mean. And now, with a two-tailed, there's going to be two z-scores. One's going to be positive, one's going to be negative. And you're going to shade, again, in the tails. So, the p-value, in this case, is the sum of the shaded area. And they are symmetric. So if you can find the area of 1 and multiply it by 2, you'll get the total area. And so that's the hint for this one. It says find the p-value for a right-tailed test and multiply the p-value you find by 2. So 6 says compare the p-value to the significance level alpha. So we're going to take the p-value we find from our actual data to determine and compare it to alpha. Then we're going to decide whether or not to reject the null hypothesis. So if the p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. And then we write a conclusion. And so, again, every author, every person is a little different, but it also is the same idea. 8 says, so at the alpha percent significance level, so maybe at the 5% level of significance, the data, and you could say provides, or you could say does not provide, depending on what you conclude. Does not provide sufficient evidence to reject the null hypothesis and conclude the alternative hypothesis is true. Or you could say something, there is not enough evidence at the alpha percent level of significance to show that blank, 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 dot, 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 and then state the claim that was made. So just, again, every book has a slight different verbiage of a conclusion. So you'll see that in your homework, and you'll see that as we go through. So it doesn't mean if you don't say exactly what I say, it's incorrect, but it should have that same idea. Are we concluding or, rejecting, failing to reject the null hypothesis, okay? So in our next video, we'll actually go through and do our first example.